Hello everyone. Happy New Year. This is React Native Community Meetup number 6. First time in this year and first time in English. We have plenty of guests here who may not speak Polish that well. So it's looking promising for the next meetups. We might be actually continuing this. Yeah, and yeah, so the plan was for today to have two speakers. First one supposed to be Mateusz Zatorski. Apparently, he had developed a stomach flu yesterday, so it's even. It's kind of better that he's not here with us today. But anyways, yeah, this is a loss perhaps for everyone here. So to compensate for that, we had to figure something out, and to keep you entertained, we have another presentation from by Tomasz from Software Mention, but he'll be presenting after the break. I'll be also speaking a little bit about React Native Reanimated after that, and also have prepared a short presentation on React Native news. So the plan for today's short is I'll be showing some news from the React Native world now, and then we have Satya, who will be talking about the new architecture, React Native. Is that correct? Yes. And then we'll have a short break. We might have something to eat here. I don't know. Do we? Will we? Yes, I think so. And then we have Thomas, and I'll be also speaking after the break. So yeah, I hope you enjoyed it. And we're also recording for the first time, so it's even more apparent because we only have like a couple of hours to prepare our presentations. So yeah, let's see how it goes. And yeah, thank you for coming. Right, so we will start with my short presentation about what's new in React Native. So this is essentially like just a list of tweets and screenshots I had prepared shortly before this this meeting. So yeah, let's see what new things have happened in the React Native world in the past like couple of weeks. So I have some tweets here. First one is from Svetan from Facebook, and he tweeted that they landed a 5% memory win in Hermes. Hermes is a JavaScript virtual machine developed at Facebook specifically for React Native apps. It is currently available for everyone to use it on Android. Given that you have React Native at version 0.60, I think that's the lowest one. And the difference between Hermes and the previous or the other virtual machines that can be used with React Native is that Hermes in the release mode is able to process a sort of bytecode compiled version of JavaScript. So we don't need to deal with a loading JavaScript bundle and parsing it, which improves the startup time and also memory usage. And here we see that some other memory improvements have been made to Hermes. So it's worth giving a shot. Facebook is working on it, and we will likely see other improvements like that happening in the future. Next one is about the Expo SDK 36 release, which happened just before the holiday break. So yeah, a lot of things changed. New APIs been added. The React Native 61 support has been added, which means that with Expo you can now use the new reloading thing, which is pretty cool. So if you haven't migrated to 36 and you're using Expo, then it's definitely worth doing that soon. We'll have another SDK release perhaps in a few months. There are a few people here who work on Expo SDK, so you can get them. There's Thomas over here, and there are also other people around. So you can chat with them and ask about what's new specifically in Expo, and they'll definitely be able to share more details than I do. Yeah, so there are more companies adapting React Native. So here's a cool blog post made by the guy from Activision, where they use React Native to build a companion app for the Call of Duty game. Yeah, recommended. this article. Really cool stuff. Next up is another app. It's the Coinbase app. Coinbase is one of the biggest cryptocurrency trading platforms. And they've published their iOS app a few months ago. Like just a couple of days ago, it went live on Android too. So they're sharing code with React Native. Have the same Coinbase Pro app that runs on React Native and on both iOS and Android. Even more apps using React Native. I think everyone knows that Microsoft is highly invested in React Native. And they've just published a Microsoft Edge app that apparently also uses React Native. So yeah, you can see some of the project like React Native FedDrop or React Native gesture handler being used by the Microsoft Edge app on the iOS. And not only apps actually use React Native now, because we even have a whole operating system that is built on React Native. So this is it's called LiteOS, and it runs on a Lite phone 2, which is like a very tiny device with a electronic ink display. It doesn't have you cannot really run like a fancy animations on it because the refresh rate on that screen, electronic ink, is like 2 frames per second or something like this. It just takes a very long time to refresh that type of screen, but it consumes not a lot of energy. So with such a phone, the battery life is just like much longer than with usual phones. It's built on top of Android actually, and the whole UI platform built for this is in React Native. So whenever you actually develop an app for the LiteOS, you would, instead of doing this on Android, you would actually do it in React Native. Also really cool article. I recommend reading it. What we have next? Yeah. So State of JS has been published in December last year. So if you're interested in stats and analyzing different metrics, that's a place. That's a web page you want to check. It's stateofjs.com. There's a section on mobile and desktop. There's React Native there. There's Expo, and just a lot of information from their polls. So this is definitely subjective, but anyways, worth checking if you like playing with data and interesting in stats. And we also have App.js, which is happening in April, which means we have less than 100 days until the conference. So this is the conference that we organize here in Kraków. Along, like Safra mentioned, my company, along with Expo, does this. So we'll have a lot of speakers from Expo, and not only just the list of speakers is on the website is still not yet complete. And if you're interested in coming, we have you can subscribe to our newsletter. We have Paulina is doing that. Yeah, we have some discounts that we will sending over. So talk to Paulina if you haven't yet, and ask for the discounts. And that's it. So we will now move on to the presentation on the new architecture of React Native. So yeah, give a clap for Satya.
Hello everyone. So today I'm going to talk about the architecture of React Native. We'll take a look at the current architecture of React Native, and then see what are the problems with it, and then discuss the new architecture. So first, some things about me. My name is Satyajit Sahoo. I'm a front-end developer at Callstack in Wrocław, and I work on React navigation. You can follow me at Satya164. So first of all, React Native. What is it? I mean, I know all of you know, but still. It's a library to build mobile apps using React. It was open sourced back in 2015. Officially, it supports Android and iOS in code, but there are other projects, like there is a fork by Microsoft, which is for Windows. So you can use React Native to write Windows app. and there is React Native Web, which allows you to write React Native apps for web. There is also React Native Tizen, which allows you to write React Native apps for Tizen. So how does this work? How can we build apps for so many platforms with React Native? So React Native is built on React. React is a library that lets us use our UI in a component-based API. It's independent of the platform and can be used on any platform. So to integrate with the platform, in React we write something called a renderer. So for example, we have React DOM. With React DOM, we have a renderer for DOM. Then we have React Native. We have a renderer for React Native. The core React library contains a diffing algorithm, and the core API, like the component API or hooks. Those kind of APIs are in the core React package, and there are other packages such as React DOM and React Native, which contain renderers for DOM and native. So the renderer is basically kind of an object. In that object, you have different methods. Those methods tell React how to manipulate the native platform. Like in DOM renderer, it will tell React how to, like those methods will allow React to mutate the DOM. In React Native, those methods will allow React to mutate the native platform. So on a high level, like when you write the UI code, first of all, what happens is our app renders. So say you have view or text. When our app renders, the React library uses the React Native renderer. And then this renderer takes whatever you have rendered and then renders them to the native platform. So how does React Native renderer know what to render, and how can it like render to native platform? So for like integration between JavaScript and native, we have like two mechanisms in React Native. We have native modules and we have view managers. So native modules are like very simple like classes where we have certain methods, and those methods can be exposed to JavaScript. So you access a native object, and that object has certain methods. You call those methods, which will call those corresponding methods on Java or Objective-C. View manager is a bit more complex. View managers are for native views, such as image, scroll view, those kind of things. And they tell React how to render those native things. They are exposed to JavaScript as a string. Usually, they are called React tag. For example, there is RCT view, which corresponds to view. There is RCT text, which corresponds to text. So it's very similar to how it is on the web. On the web, you have div, we have span. Those are not normal React components. Normal React components are functions. But div is a string, span is a string. So when you say you write like div, React knows how to take that string and render it. Similarly, in React Native knows how to take RCT view and how to render it. So this rendering happens via native module called UI manager. So it kind of looks like this. We have certain methods like create view, update view, manage children. Like when initial render happens, it calls create view with a tag name. When you update props of a native component, it calls update view. When you change the content, it calls manage children. So, okay, so these are the methods that it calls, but how does it actually call? Like we have JavaScript, but how does JavaScript call those methods in native? So in React Native, there is this thing called the bridge, which is used for communication between JavaScript and native. So what the bridge is a like queue. This queue is for sending messages between JavaScript and native, and all of these messages, they are like JSON objects. So when you want to call a method, that method is sent as a JSON object to native. Then native knows how to execute that method. So also all of these messages are bashed together, and this bridge is asynchronous. So you call a method, then it gets called in native asynchronously. So it doesn't block the JavaScript thread. So this works great. This is kind of how it looks. We have create view. For example, a create view call. It goes in an array where you have the name of the method that needs to be called. Then you also have all of the list of the arguments that needs to be called. I mean, it looks a bit more complex like that, but this is a simple representation of what happens. So all of this information goes to the native, and then the native executes it. Actually, like I wrote like JavaScript and native here, but there are actually like 3 different threads. We have a JavaScript thread, we have shadow thread, and we have UI thread. So the JavaScript thread is responsible for executing all of the JavaScript. For example, all of the user code that you write, and all of the library code such as React. Then there is a shadow thread. Why is it called shadow thread? Because it contains a tree called the shadow tree. This shadow tree is a representation of the UI tree that you write in JavaScript. It's like kind of a virtual DOM. It's not virtual DOM, but it's kind of a virtual DOM. It's basically a copy of virtual DOM. So this shadow tree receives all of the commands from JavaScript. Then in this tree, it calculates what to render, calculates the layout using a library called Yoga, and then everything is rendered in UI thread. So I also want to say something about Yoga. Yoga is basically a C++ library. It's a layout library. To understand it, we have to understand that the native platforms like Android and iOS do not use CSS. They have their own layout system. So when we want to write styles in React Native, we write Flexbox. We write like CSS-like property names. They are not a native layout system. So React Native needs to convert this style sheet API to native layout system. So that's what Yoga does. It basically takes all of our styles, calculates how to position everything, and it positions everything absolutely, and then renders them in the native thread using the native layout algorithm. Sorry, API. So let's go back to our UI. The flow kind of looks like this. Our app runs. The initial render happens. It creates some views, which creates shadow nodes. Then those shadow nodes are rendered to native platform views. So all of these is asynchronous. You call, you don't get immediate response back. It doesn't block the JavaScript thread, which is okay. But this works great for some cases, but not great for other cases. And we'll discuss in which cases we want synchronous calls, but sometimes we need synchronous calls. We need our UI to be updated synchronously, not asynchronously. So first of all, that's one problem, asynchronous code. Second problem is initialization cost. As we discussed, there is this bridge. When you launch a React Native app, the bridge needs to be initialized. And when the bridge needs to be initialized, it also initializes these things called view managers and native modules. The lifecycle of view managers and native modules is tied to the bridge. So if you have, say, lots of native modules and lots of view managers, it slows down the initialization a lot. Okay, so the next thing is everything is serialized. When you send something via the bridge, it is serialized using JSON stringify. So, which means everything you are sending needs to be serializable, first of all. And if you're sending a large amount of data, it needs to be serialized when sending, parsed when reaches native. Then when native needs to respond, it serializes that response again. Then it is passed again on the JavaScript thread. So there is a lot of copying of data between two threads. Instead, we could share the memory instead of copying, which would improve our performance a lot, because we don't need to unnecessarily copy data between native and JavaScript, and we don't need to unnecessarily serialize and pass every time we need to send something. So one common issue people have with this is sometimes they are like sending images which are like large binary data. They are converting it to base 64 so that it's a string that can be sent. So they are sending this base 64 string to native and then sending it back to JavaScript, which is very costly. And it can block everything else, every other call, and it can make the app feel very sluggish. So another problem of this is the layout system. So right now, since layout is on shadow thread and we communicate with it using the bridge, layout is asynchronous, which means we cannot know the layout synchronously. On web, if you create a div, you immediately know how big it is or how wide it is. On React Native, we have an API called onLayout, but it's called like this. We render, then the view is created on native side, then onLayout happens, and we get a response back, but it is asynchronous, and by the time we get this call back, UI is already rendered. So if we change something after that, the previous result needs to like get updated. So we can see a flicker when that happens. So we need synchronous API for that. So there are some other APIs such as like gestures. With gestures, we might need to call back to JavaScript. Say we are moving an object, and we like reached a point where we need to release an object or something like that. So we want to call back to JavaScript to execute some JavaScript logic to check if we can stop or we should continue. But it is not possible with asynchronous API. We can do other things like pre-compute those values and send them, but it's not very natural if you couldn't like normally write the API that you would write. So another thing is list view. So in React Native, we have flat list and other virtualized list, those kind of things. But since layout is asynchronous, it cannot measure everything like as fast. There is always a delay. And if you're scrolling very fast on a list view, you can always see some empty space at the end. It's because our scrolling and all of the scroll events and all of the layout events, they are not in like perfect sync with what is being rendered. And there is a delay. So with a sync API, it can be improved a lot. So another small API like that example is backhandler. You might have used backhandler if you are writing React Native app on Android. In backhandler, we attach a listener, which is called when back button is pressed. And in that listener, we can return true if we handle the event, or we can return false if we didn't handle the event. So if we return true, what happens is it blocks the default action of the backhandler. So the default action is usually exiting the app. But it could be something else, like if you override something in native, it could be something else. But right now, React Native will always exit the app because it's not possible to have synchronous calls. So React Native implements it in a hacky way, and it calls back backhandler.exit app directly if you didn't return true. So yeah, like there are a lot of other APIs which could be improved with a synchronous call. and the current bridge infrastructure doesn't really support it. I mean, you can actually write a native module which has a synchronous method. There is this annotation called, okay, is blocking synchronous method or something like that. On Java, there is something else on Objective-C, but there is an annotation you can provide, and it will make that method synchronous. But it's not enough because a lot of other things like events or like callbacks, they are not synchronous. And this is blocking synchronous method is also not documented. All of the native modules are not using this. All of the native modules which are present in React Native are asynchronous. So it's not really a solution, so we need something better. So this is the better thing. To solve these problems, like React Native went through a large re-architecture. And it introduced this API and this thing called JSI, which stands for JavaScript Interface. So this is a new mechanism for communication between native and JavaScript. With JSI, we can have objects in C++ which will expose their methods to JavaScript. So JavaScript can have a reference to an object which was instantiated in C++, and it can also call methods directly on that object. So there is no like data transfer between two realms. So this JSI is the basis of like a new API for view managers and native modules. So the native module API will be the same, but all of the view managers we have need to be rewritten because of the new API to be able to like support rendering synchronously. So to understand how this JSI system works, we can like take an example of web. If you are familiar with the DOM API, we have this API called document create element. Say we want to create an image element. We call document.create element, which returns a image element, instance of image element. So that image was instantiated in JavaScript, sorry, browser's C++ code. It wasn't in like pure JavaScript. But now we have a reference to that. Then we can call methods on this element, like set attribute. We can update the such attribute. And this set attribute will call some method in C++ to update the src property of this image. So similarly, we can have the same thing in React Native. Like this API is not the actual API, but I'm just showing on how it will work. So instead of document create element, you can say UI manager create view or something like that, and it will return an instance of image. And then you can call set native props on that, and you can update any property synchronously. So with this, you can also like pass booleans, maps, which are converted between JavaScript objects and native objects seamlessly without having to do anything extra. So because this JSI is based on C++, like to expose stuff to JavaScript, we need a C++ class. And we can write this C++ code by ourselves, but it's just repetitive task which we don't have to do by ourselves. So instead, what we can do is we can write a flow interface or a TypeScript interface, and there is a code generator which can take this interface and generate all of the C code automatically. So this is a project called CodeGen that Facebook is also working on. Right now, I think their implementation only supports Flow, but in future they plan to add TypeScript support, or they want the community to add it. I'm not sure, but it will support TypeScript eventually. This has another advantage. Since we are writing TypeScript interface by default, all of our communication between native and JavaScript is now type safe. Like you'll get autocomplete, you'll get error checking, and it's harder to have runtime errors because our JavaScript code and our native code didn't match. Yeah, so it was JSI, and after JSI, another big change in React Native is Fabric. So Fabric is built on top of JSI. While JSI only dealt with the communication aspect between native and JavaScript, Fabric deals with the rendering. So in the current architecture, all UI operations are handled by UI manager. But in the new system, all of the UI operations can be directly exposed to JavaScript. Right now, when you want to update an element, you have to call UI manager.updateView, right? I mean, you don't have to call, that's what React Native renderer calls. And when you do that, it sends some commands via the bridge to native to update those views. But in the new system, what you will be able to do, you will have an instance of image or whatever element we have, and the React Native renderer can call methods on that instance synchronously without having to go through the bridge. So that's what Fabric is. It also introduces a new threading model for the UI. Like right now, we have three different threads. We have main thread, we have shadow thread, and we have JavaScript thread. So instead of like having three different threads to do everything, we can do layout synchronously from any thread with Fabric. Like we can call a layout from JavaScript, or we can do it from native. So to be able to do this shadow tree has to be like immutable, because otherwise it won't be thread safe. Otherwise, like if one thread modifies it and other thread doesn't see the update, then it will be a problem, right? So yeah, because it is immutable, every time you change it, it will create a copy, and this copy will be visible to each thread. Okay, so Fabric will also introduce new functionality to React Native. You might be familiar with React Fiber. So React Fiber is basically asynchronous rendering in React. You might have heard about Suspense. At least Suspense is built on top of React Fiber. Suspense works because React can handle asynchronous rendering. So basically what asynchronous rendering is not the same as the asynchronous rendering we talked about earlier. Like what we talked about earlier is everything you do is asynchronous. But with React Fiber, React has two different priorities. It has synchronous priority, it has asynchronous priority. I mean, those are not priority names. It has low priority, high priority. There are like 7 different priorities that React has, but we can probably like summarize it to 2, low priority and high priority. So what is high priority called? High priority. Say you're typing on input. When you are typing, you need to see your like the input update like as soon as possible, right? That is high priority update. If you're animating something, you want it to happen at 60 frames per second. That is high priority update. If you're doing a gesture, you want the whatever element you're moving to move as with your finger. It cannot be slowed down. So those kind of things are high priority updates. And then there are low priority updates like network calls. If you're fetching some data, it doesn't matter if it gets delayed by 2 milliseconds or like 5 milliseconds. It doesn't matter, so it can be slow. So what React will try to do, React will try to always optimize your high priority work, like gestures or animations, and try to delay low priority work. So that's how it can keep our UI responsive, because work which is not visible to user in the UI can be delayed to unblock other work. So it kind of deals with scheduling. It's called cooperative scheduling. So different parts of the library, different jobs cooperate with each other, so that the job which needs to work more gets the chance. Okay, so another thing is with Fabric, we also want to make the bridge lighter. Like it needs to be more simplified, and not having to do with all this serialization, so that it's faster and more efficient. And in future, as far as I know, there is also plan to have a bridgeless mode, so there won't be any bridge. So one problem with this is, so right now, since everything is asynchronous, there is actually an advantage of it. You might have used the Chrome debugger. So what happens when you connect to Chrome debugger, all of your code is sent to Chrome. So all of your JavaScript is running in Chrome, and it connects to native via WebSocket. So instead of sending data via the bridge, now it's sending data via WebSocket connection. So now JavaScript on Chrome connects to native code on your device. So because it is asynchronous and everything is built to be asynchronous, it is working. But when we have synchronous calls, this won't be possible because WebSocket connection is asynchronous by nature, because it is connecting to a different device altogether, so it cannot be synchronous. So that is something Facebook needs to figure out. They are now building tools like Flipper, which integrate with React Native to make debugging easier. You can right now also debug your React Native app on Safari, but it's only for iOS. On Android, it cannot be debugged using Safari. So that's something to figure out for Fabric. I heard that they already have something, but it doesn't work in open source yet. So we'll see. Yeah. So if you want to know more about this re-architecture, or you want to know more about Fabric, you can go to this URL. Basically, this repo discussions and proposals in React Native community, and the 4th issue. And you'll find a lot of links to articles, videos, talks about discussing different aspects of this new architecture. And you could also leave a comment there if you have a question, and somebody from Facebook will reply to you. So yeah, so you can do that. Okay. So thank you. I hope you learned something about the new architecture.
We'll still have some time after the second part to discuss and chat and network for networking. We'll need to move on with the program. So as I mentioned earlier, apparently Mateusz, who was supposed to present on writing apps with less bugs, he apparently got sick. We just got not message from him today. He was actually yesterday at our office. He traveled 300 kilometers here and got sick just a few hours before presenting. So instead we will have Tomasz from Software Mention presenting on React Native for web. So as I mentioned, we only learned about that Mateusz is going to miss the meetup today, so we didn't have too much time to prepare. Tomasz didn't have too much time to prepare, so keep that in mind. and yeah, can I get a round of applause to Tomasz for preparing on such a short notice? Thank you. So, you good?
Hi. So I'm Tomek, and I prepared a quick summary of React Native for Web for you. What is it, why is it useful, and how it works? React Native for Web has been around for a while, and I can say that I have personally avoided it for quite too long. If you haven't had time to check it out and find out how it works or what are its possibilities, you might find my talk a bit useful. If you know what is React Native for Web, there will be nothing new for you. Okay. So let's start. My name is Tomasz Czajęcki. I am a software engineer at Software Mention. I'm using React Native for the past 2 years, so that is my experience with the framework. My Twitter handle is Czajen if you want to follow me or anything. And I didn't know, as Krzysiek said, it was a bit surprising to me that I will be talking today to you. So I did my best, but maybe it wasn't enough. We will see. So in order to understand the importance of React Native coming to web, we should have a look at how the idea of being cross-platform evolved in our community in the past. So when React Native was at its early days, we as software houses, we would sell it to clients saying that we can make them just one mobile app instead of two. So essentially they would cut production costs up to a half because we would be just writing one app instead of two. So even though it often replaced one kind of problems with another ones and brought others of its own, in retrospection, we can't say anything other that it changed how we create mobile apps today. Back then, let's say in 2016, it was question whether we want to risk picking React Native or not, because the writing native apps could have been better. But today, it is obvious choice that for majority of projects, we will suggest clients that they should definitely go with React Native, and that will save them a lot of money, just like that. And things has changed. It is now, as I said, really obvious that we probably want to go with React Native, but another question is recently coming to us. So we are wondering if we can merge our React and React Native code bases into one and just reuse the whole code, or as much as we can, like 95%, 90%, and not just write two separate apps. That's where React Native for Web comes, and I will try to introduce you to how it works. So before I move on to the details, it's important to realize what reasons exactly might motivate us to invest into bringing React Native to the web, because we already have React for the web, so it might not make much sense to have React, then have React Native, and then put it back to the web. It's a full circle, and there must be a really good reason for us to do something like this. So obviously, less code means less bugs. Anyone who is writing code for a longer period of time knows this. And yeah, we all know that programmers won't introduce bugs to the code base if they don't have a chance to write more code. And less code means less developers, which leads to lower costs in many ways. Because effectively managing big teams remains a bit of a mystery in our industry, because it's not something we are taught at the universities. We know how to write sorting algorithms or solve graph problems, but nobody really teaches us how to work in teams properly and not mess up huge code bases. So definitely keeping programming teams smaller is a kind of plus. And one source of truth for business logic, it is quite an important point, because writing code twice is really easy because we can just copy and paste it, and it takes literally no time to have two copies of the same code. But managing and updating code in two places and testing potentially two absolutely different behaviors is something we are not really good at. So this is an advantage that we can't really ignore. And ideally, we would also enjoy having one source of truth for styling. Nowadays, it is really I would say, popular for companies to invest in design systems and make their apps look more coherent and just less chaotic on the UI side. So having just one place, one line of code that controls how, for example, border radius of a button looks in the iOS, Android, web, responsive mobile web, and potentially Electron app is definitely a great thing. So I will be gradually moving from having no shared code bases between React and native app to a fully shared solution as we can have it as of now. So first thing is code sharing. I am a huge fan of saying that the best code is no code at all. And the best contribution to a repository is the one that removes more lines of code than it adds, because it makes apps less complex. It is not always true, but generally keeping things simple is a good thing. So before we move on to adding a whole new framework to our project, let's see what we can achieve with no extra code. And React is by design pretty shareable. It shares markup syntax with HTML or XML, to be precise. So in the first place, it's a tool for component composition, and we can definitely use that fact when writing higher order components and so on. They are just generic by design, and we can reuse them anywhere we want. JavaScript works the same way on both React Native and React web platform, and that was the point when creating React Native. So most of the business logic in some way can already be shared easily. It's just not that tied to the framework itself. And of course, hooks work in both React Native and React DOM. And even React components do, just with the exception of native HTML elements and native primitives on the web. In the mobile platform. In the mobile platforms, they need to be replaced in some way. But other than that, we can share quite a lot of code without adding anything to our project. So what is actually missing before we can, for example, share code of the components? Next step will be replacing divs with views, or the other way around, because those are two primitives for web and mobile platforms, and we can't really skip that problem. We will have to eventually replace one or another if we want to ship code for web or mobile. Then we need to remember that text in React Native needs to be wrapped in a text component, because strings of text aren't first-class React nodes in the web, in the mobile React Native, due to the way that native platforms render text. And styling is a bit different, because styling in React Native resembles CSS, but not exactly, and there are some differences in that. So there's a library called ZAX, or Zero Abstraction Cost Styling, created by Radek Pietruszewski from Nozbe, and it allows us to share components between web and mobile with a use of a Babel plugin to transfer code depending on the platform. So essentially, it achieves that goal we had to have one component written and render it to two platforms. So if it is all we wanted to have, we can just stop now and happily develop our application. If not, we need to go further and look for more complicated solutions. So we enter React Native for web now. The most surprising thing about React Native for web is how old it actually is. Because due to the Expo for Web, which was introduced last year, the topic of bringing React Native code bases to the web, or just essentially increasing the portion of our code base that is shared between all platforms. So it gained a lot of popularity. But yeah, I found it quite surprising how old the whole thing is. The first commit to React Native for Web dates back to June 2015. So if you think about it, the solution to our problems was there for like 3 years or more. We just ignored it, and we ignored it for several reasons. It was maturing over the years, and it wasn't that ready back then. But now in 2020, it makes a lot of sense to use it. So how the whole thing works. React Native for Web is essentially replacing a React Native package when you are loading code in the web. If you visit its GitHub repository, you will find that they link to a code sandbox example app, and using it is as simple as that. You just have to add React Native Web as a dependency, and you can enjoy writing views and text components in your web app. But to make it really that powerful solution for sharing code anywhere that we wanted to have, we have to find out how to create a project that includes both native apps and the web app. But I will talk about it a bit later. Before I will explain what comes included in the library. So the first thing are the primitives for each platform, essentially view and text, that will allow us to share components. We gain access to special extensions, just like we have some file name .android.js for creating files that are used just by the Android repository. We also have something like that in the web. We can use filename.web.js and filename.native.js extensions, and that way we can actually implement the differences between platforms that our app is written to. We also, of course, gain another OS in the platform package in React Native. And what I find the biggest reason to use React Native for Web is that it ports a lot of non-obvious APIs to the web. Like, for example, Animated API or Pan Responder. You can finally use the same animated code in the browser that you can use in your React app, which is a bit of a game changer for many apps. And what I found problematic about it is that setting it up for multiple platforms isn't that easy. If you wanted to share code and use Yarn Workspace to group your app into several directories, you would have to, for example, create React app, use create React app to create the web app, hack it to use the code outside of its src directory using a rewired package for create React app, because you would have just one directory with React app, then another with mobile app, which you would also have to hack a bit, because React Native is assuming that Node modules will be sitting in the same directory and use its files, so you will probably have it in a directory just a level or two above. And you would have to accept that VS Code occasionally goes crazy, because it's not obvious what kind of TypeScript definitions for React Native should be used when highlighting the code when you are having a project with React app and web app. I just find it a bit complex at some point for it. So now we enter Expo for Web, which was released last year, and for me it was really a game changer that I didn't expect. because I didn't assume it would change that much, but it did. We can now use exactly the same code base located in just one directory. We don't have to split it into several ones. Of course, as it comes with regular Expo apps, we lose some kind of control over the exact code that we have there. But even after that, framework gives us ability to overwrite some files, for example, index.html or service worker files. It's really easy to customize. And just to clarify, Expo for Web is using the React Native for Web that I was mentioning the whole time. It just brings it to the Expo ecosystem, and I can say that it does it really well. So yeah, you can enjoy all the other features of the Expo ecosystem using it, which is also a huge plus because Expo now is a huge collection of very useful modules that help you when developing apps, and they are constantly working on bringing other modules to the web, like just giving it a proper web support. So I have one code example to show you where React Native for Web really shines, in my opinion. One time I was able to create a spinner component that would work exactly the same way in the iOS, Android, and web apps because I used Animated API and it just worked just like that. It was really cool. Another good news is that if you know React Native Gesture Handler and React Native Reanimated, which essentially became tools that almost every React Native developer uses nowadays, they are now also present on the web, thanks to work of Evan Bacon from Expo, who was also working on the Expo for Web. They are now implemented in the browser and can be used for all the things that we could use them in the mobile. So a quick summary of what I just talked about. React Native for Web is finally allowing for full React code reuse between web and mobile. I am saying finally, but it's not really true because, as I said, it was there for quite a long time, but I guess we just didn't notice it or didn't really use it. And Expo for Web is a really handy tool, and in my opinion, it significantly increases developer experience. Currently, there is no easy way to merge existing apps to native ones without some special cost to that. You can, of course, import React Native for Web to your web app and gradually move components there, but it will cause problems with increased bundle size and so on. But on the other hand, I can see a lot of reasons to go with Expo for Web in new React Native projects, and I now can't imagine a fast-pacing startup or another product picking any other tech stack than Expo for Web, because it just allows to move so quickly having one code base. It's something I wouldn't be able to imagine back then in 2016, that we would just write one component and have it on any platform we want. So that's it. Thanks for listening to me, and I hope you are able to learn something new about React Native for Web if you didn't know it. And if you did, it could be a bit boring to you, but sorry. Anyway, thanks for listening. That's it.
Thank you, Tomasz. So Tomasz will be answering questions after we're done with the program. And as I mentioned at the beginning, I also prepared a little bit like a short presentation. I wasn't really expecting that we'll finish that late, but this should be. I'll try to squash it within like 15 minutes. So yeah, feel free to leave at any point. But yeah, I'll be actually talking about React Native Reanimated because we recently, we've recently at Software Mention decided that we will invest more in the open source libraries that we are developing, and among those libraries we have React Native gesture handler, we have React Native Reanimated, and we have React Native screens. There are perhaps a few other libraries that we do, but in essence, we also decided that we'll plan on like setting up some goals and roadmap for what we want to achieve with the libraries we have. So I haven't really shared this publicly before, but just wanted to like show you a high level ideas of how those libraries will evolve and what are our goals for the next couple of months. Most of the stuff here isn't ready. It's like on the works, or like some of the parts we have actually just started like a week ago or something. But yeah, we have some vision, and that's what I wanted to share today. So the title is called Reanimated Journey to 2.0 because Reanimated currently is at the version 1.7, I think. Yeah. So the goal of Reanimated since the project started was to bring a power of writing any sort of animations or gesture-based interactions in React Native that could run on the UI thread, unlike the previous sort of or like default implementations that use those like JavaScript thread run trips to perform changes. So this is what actually like Sadia was mostly talking about, having those asynchronous threads, which makes it difficult to run interactions that are snappy or smooth enough that like especially when you interact with the screen. So like if you haven't heard of Reanimated, one thing I would recommend you checking out is a YouTube channel of William Candelian, who is like building crazy stuff using Reanimated. And especially if you haven't heard of Reanimated, I recommend checking it out, because then you like figure out why is it so difficult to build stuff that he's building. But regardless on that, it actually unlocked a lot of possibilities in React Native specifically. Like I'm talking about Reanimated. So one goal was to make it possible to actually have or be able to write those interactions, as it just wasn't really possible in many cases before. And the second goal, which we actually unveiled last year, was the API we called transitions, and the goal of transitions were to make it so that we can use platform native APIs for animations from within React Native. So React Native in general, like one of the coolest thing about it, in my opinion, is that it actually allows you to use those native API, unlike other like cross-platform solutions, which basically usually like tries to or ship or use different rendering engines. So they cannot really allow you to interact with platform native APIs, while with React Native you still can, which like it's a biggest differentiating factor in my opinion when it comes to React Native. So with animation, it has never been the case. So both iOS and Android have its own like animations library. We just couldn't be using it, and that's what transitions was attempting to do. So with transitions, we had those like component based definitions of like what's going to happen on the screen, and then you could like sort of control, like orchestrate the animations on the screen. So this is something we introduced last year. But there was this thing, like whenever you wanted to actually like animate the changes on screen, you would have to call this method before you like change anything in your component. But once you did, like once you changed it, it was like pretty automatic. So it would figure out like what changes and like how to animate those changes. I could, for example, define that you want to animate whenever like a new item appears, then it will be faded in, and when it disappears, it will like scale out, and when there are changes, it will like move. So this is essentially what transitions will allow you. But while like from the experience using it for a couple of months, like since we actually started, since we like published it, we yeah so we essentially found out that this isn't really like elegant enough, and it's not that useful in many cases. It like complicates a lot of things, doesn't really bring a lot of benefits. So with in the next release, or like in the 2.0, it's not going to be the next release, but hopefully like once a year. And then with redesigning the transitions API, you will no longer need to actually call to this. So we want to make it like fully automatic. And I didn't have really time to prepare slides, so I'll just show you the code maybe. So the new transitions API will allow you to animate changes. And it works this way. So what you would have is like a component that will have like some state. This is actually provided from the parent component, and whenever this state changes, you could pass different styles to the component. So in this example, it's like a transition in text. You could have like transition in view, and this component will like, once the state changes, it will try to animate between those changes. So this is something more familiar if you've been using like Animatable, and this is the same kind of API, but in case of Animatable, it actually like drives those changes from JS directly, whereas with Reanimated, you are using native platform native API for running those animations. So for example, on iOS, you would be using core data. So you can do cool stuff here. You can like animate the text properties like this. So it just changes like a font size. I'll just make it bigger. This way maybe. Yeah. You can do also like a font weight if you want. Just get bold, or like a color, or anything you want actually. Like most of the properties that the platform supports, so it will just animate between those two colors. There are other things. So you can like change the background color of elements, so this animates smoothly. So if you want to tell like this is running the platform native animation framework, you can use with simulator on iOS. This is this option like in debug slow animations, and then you will see like them just flying slower. And because it's using platform native animation framework, those animations are also interruptible. So like you can just like stop them in the middle and it will return. I'll just click that twice in the middle of animation, so it doesn't need to like go to the state that you wanted at the beginning and then go back. There are other things you can animate, like border radius, also stop at any place, and or size. So this is for transitions. So this is what's coming in Reanimated 2.0. There are a couple of other things just wasn't didn't have enough time to prepare or present, but I'll be happy to tell you more about it after the talk. So this is for transitions. But we also have like a pure reanimated API that I refer to nodes. So we have nodes, and like people have been using reanimated nodes specifically. Like you could find a lot of like use cases for the nodes based API in Williams videos. It was like doing the job. So it was giving you a way to define those interactions that you would not be able to do otherwise. But there were some issues with it, and specifically, a lot of people have been complaining about a couple of things. So the main issue, I think, was like the startup performance of that API. So, whoops, yeah. So because in many cases you would actually have like a lot of nodes. You can actually check like one example here. This is the example. I just change it here. Oops. Yeah, so this is the example of like a box that you could drag and it will snap to either like right edge of the screen or left edge, depending on like how fast you drop it or like how close you are to each of those sites here. Because so it bounces as well. And it's here, and you have like a lot of those nodes here. As if you're familiar with Reanimated, I know what you know what I'm talking about. So yeah, in order to define this interaction, you would actually need to have a lot of those functions. We actually refer to those functions as nodes because each call of that function generates a object that then is copied to native so that it can be executed on the UI thread. And we call those objects nodes because they're linked based on like which object is an argument of which other method. So we essentially create a graph of nodes that we then execute on the UI thread. So we have a lot of nodes, and because of those nodes, we have memory overhead because we need to copy them. We need to create them in native. We need to copy them over. We need to create them in JavaScript. We need to copy them over to native. We have a CPU overhead because just like in many cases, I've seen like samples that would have like 5,000 nodes or even more than that. So it's actually like pretty common that this happens, and in many cases it just like it performs fine enough, but there are cases where it's just not sufficient. And the second problem was that it's not really very intuitive for people to use. I mean, depending on like the background you come from, it might or may not be intuitive to you. I'm actually like a Lisp junkie, so it is intuitive for me. I'm used to writing Lisp code, and this is essentially like almost like writing a Lisp, except the braces are in like a different place. But other than that, it's pretty close, right? But for many people, apparently it's not intuitive, and they have problems figuring out like how to do this and how to write that kind of interactions. So we had all those problems actually coming from one source. So the source is that we have the API designed this way. We have those nodes. So when you have a problem with something, what can you do? You can like get rid of it, right? So we'll be perhaps doing like getting rid of nodes in the Reanimated 2.0. And the way this could happen is by making it so that you could actually define the interaction in JavaScript. And what we'll be doing under the hood is we'll be taking your JavaScript code and trying to execute on the UI thread. So how is this going to happen? So we actually got inspiration from a web spec project, which is called like Houdini. And there is this thing called animation worklets. And animation worklets work in a way that they allow you to define like a small pieces of JavaScript where the only thing you do is define the interaction or like what's going to happen during the animation. So they need to be lightweight because you want to run them in the UI thread. So those should not be like a full React re-renders because full React re-renders often takes a lot of time and they just won't fit into like a single frame time. So those animation worklets needs to be simple. They don't actually have access when you define those worklets. They don't have access to the closure to everything that's like outside of the function. So you only have access to like the local context. You can have some state in it. If you haven't heard of it, it's actually been published just a few months ago, I think. Or actually, it's 2011, 18. Sorry. Yeah, it's been out longer than that, but this is like one of the ideas how smooth interactions can be defined on the web. So with the worklets, you could use them. You can actually define like a time-based interaction and scroll-based interaction. So this is pretty limiting, but it's kind of been an inspiration for us. So we haven't really like decided on the API yet how it is going to look like, but I wanted to like just show you some ideas that we have. And one idea is here. So we have this. So this is the old code base for this interaction where you have the box that you want to snap to some point. So you have like a gesture-based interaction, and then you have like an animation when you release the gesture. With the new API, you could have it defined this way. So you have like an event handlers that accept from an event who also take a context, because you will not be able to access like everything that is outside like the whole JavaScript closure. You will only be able to access whatever you will only be allowed to access whenever has been passed as an argument to the method. So you have an event object, and you have a context which will be defined later. So with the context, you can essentially set a attributes or values that you will be using during the event processing method. So in here we will have like a starting position when you like start dragging the box. So this is the position where you started. So when the box is like at the 0, then it's going to be 0, and then when you like start pulling it at the middle of animation, it will be like somewhere else. So in order to define this interaction, you would use the context, and in the context you will have like a translation of the box. So the translation will be like a starting position plus the translation of the gesture. So this is like a translation coming from the gesture event. And then you would also have another handler for the event whenever the state of the gesture changes. So in the gesture state, you have, you essentially have like the state and the previous state attributes. And when the gesture, when the state is active, it means that you're dragging. And when the previous state is active, it means that you were dragging and now you're not. So you release the finger, right? So what happens when you're dragging is what happens when the state changes and you are now dragging, we'll just like save the starting point to at the point at you're at the moment, right? So, and when you release the finger, we'll try to find the snapping point and then start the animation. So this is self-contained, and you don't really need to access anything outside of the method. And then to define the context, the animation state, this is something you would actually done inside of your component. So for the component, you would use this hook, which is called like use reanimated state, and you provide the attributes that you would use for this interaction. So in our case, we will only need to use the translation X, which is like the current translation for the box, and the start trans X, which is like the starting point on whenever you started the gesture. So those are like things that we need to have in a state to need to remember in order to calculate the interaction. And then you have a pen gesture handler for which you pass those two handlers that we talked about earlier. And in the same way as in animated, you like associate the translation X state with the translate X attribute of the view. So this is all I have prepared, and I guess it's 9 p.m. already. So so that's it for today. Thank you for coming. I mentioned that earlier, but if you have idea for a talk, or you don't have idea but you have courage to talk here next time, come to me and we'll find a topic, or we'll find the courage. That's it. Thank you.